Okay, hello, welcome to today's video. So last video we were looking at how the ideal gas thing was actually being done inside DWSim. It's very messy. Okay, so I was thinking of ways to actually incorporate this into a DWSim code. Okay, or at least a reimagining of a DWSim code. Alright, so what do I have right here? Okay, so I have an I component that is a generic interface. Okay, this is it will depend on some pump interface which we can put in there, right? And this will this pump interface is dependent on a pump class. Okay, on the pump class which I call pump selector because it selects the algorithm. Okay, some calculation algorithm. Okay, this depends in turn on the pump calculator. Okay, pump calculator, the iPump calculator interface actually depends on inlet pressure, temperature, flow rate, outlet, and your output the outlet pressure, temperature, and flow rate. Okay, the implementation of such I have one simple one called pump power. This in turn depends on a property package. Okay, iProperty package, which you have to input some sort of algorithm. It will be able to give you the methods pH flash, PT flash, PS flash, etc. Okay, the function of the property package is just to hold all the methods for flash calculation. It in turn depends on several equation of states right here. So I'm going for this. Okay, a single phase pure fluid equation of state, which can be fulfilled by the CoolProps property package or the ideal gas package. So I'm trying to make the ideal gas package, which is basically the simplest of all the packages right here. Okay, because yeah, ideal gas is easy. At least if you think of it from an engineering standpoint, it's very easy. Okay, PV equals nRT, and then everything else gets calculated. Okay, how does the ideal gas package work? This ideal gas package, remember, the whole point is that it will implement this interface of I single phase pure fluid equation of state, which is supposed to take in a package type, so you can select the package, take in pressure, take in temperature, and it's supposed to churn out these three values: density, specific heat capacity at constant pressure, and constant volume specific heat capacity, all in the right units. Okay, so this ideal gas package will implement this interface, and this will in turn depend on several things. Okay, one of the dependencies will be a CP ideal gas calculator. It will just calculate constant pressure, heat capacity, as we see here in DWSim. It uses this sort of the correlation method. Okay, returns CP in kJ per kg per mole. Okay, T is in Kelvin. At least there's thankfully there is what do you call that, comments down there. So all it does, the ICP ideal gas calculator, it will need the temperature, it will need the gas type, and then it will output the CP. Very simple. Okay, how does it get implemented? Okay, there are several ways. One is using a ChemSep library, monoatomic ideal gas CP calculator, diatomic CP diatomic gas ideal gas calculator, so on and so forth. Okay, this gas type here, I think it should be an object on its own. Okay, sort of a thing you can select from a drop down list or something. Probably deal with how yeah. Okay, so this should be an object. Okay, gas, yeah, this is a gas type or ideal gas type. Okay, so this is a new class or object. Okay, this gas type, okay, what will it have? It is the gas name, maybe the molecular weight. Okay, molecular weight of the gas. Okay, so these are the things you're supposed to input. Alright, so why is the molecular weight part important? Is because if you want to do monoatomic and diatomic ideal gas calculator, you'll need to put this in. Okay, right. Or maybe I shall not put objects down here. Maybe this will just be a string. Okay, the molecular weight of the gas will need to be put in here. Input, okay, molecular weight of gas. Okay, that's very important. Molecular weight of gas. Let's see what's the ideal. Oh, this is in per mole. I see. If I want to put out the CP in per kg, yes, I will need the molecular weight anyhow. So let me delete this branch. Yeah, I want to output CP in well, kj per kg per mole, kg per kg mole, and then of course CP in the other units as well, kj per kg, oh, kj, kilojoules per kg per Kelvin. Okay, so these are the two standard units. Okay, kj per mole per Kelvin. Yeah, but most of the time we like to use the SI units, which is per kilogram, not per mole basis. So I guess either one's okay, but I'll just put them, both of them, in the interface anyhow. Or rather, yeah, maybe I'll just leave it as the SI units. I'm not going to calculate per mole basis unless it's needed. Then I can go and put in a method down there or do something about it. Yeah, because I will not use per mole basis right up over here. I'll be using per kg kind of a basis, say per unit mass. All right, so okay, now that's settled, the then how will this ICP ideal gas calculator be implemented? Okay, one of them will be DWSIM library ideal gas CP calculator. All right, so this is the ideal gas CP calculator. Okay, what will this one will be based on the DWSIM library. What's the DWSIM library? Okay, remember I did talk about the very long XML file, which I think I have just lost. Okay, DWSIM, go to thermodynamics, and then you will see the databases, not databases, assets. Okay, and then you go to databases. I don't know why there are two databases right here. DWSIM thermodynamics assets databases. Look in the DWSIM XML, and then you see all this very important thing, like see here, liquid viscosity, ideal gas, heat capacity, so on and so forth. So all these are very, very useful. We will want to keep them, right? So yeah, we will use this ideal gas heat capacity constant ABCDE. These are the main thing. Of course, there are other things here as well, like critical temperature, pressure, volume, so on and so forth, but I will not be using those things for this case. Right. So what will it depend on? Since I need to read XMLs, I will put in a XML reader interface. Okay, the inputs are the file path and the outputs are well, I'll use the IEnumerable object. Okay, so yeah, IEnumerable, because we like to use that. Like to use this. Remember, this is under the system collections interface, so definitely I'll have to put this system collections over here because we are using IEnumerable. Okay, for IEnumerable, and then this one I will want to use it for the XML reading. Okay, we have C# and both C# and Visual Basic, both of them have a XML reader class. Where is it? Okay, XML reader class. Okay, it's available via NuGet package, or you just use the system.xml namespace here. Okay, system out XML namespace will have a XML reader, which will allow a C# library to do its thing, read XML. Okay, of course I can do it using a C# writing code from C#, or I can try scrounging around for more DWSIM code if that is necessary, but I am not yeah. So I mean there is some Visual Basic code already written for this under the, where is this? Yeah, under thermodynamics base, there's a XML or load data. Okay, so there's already some sort of a XML thing down here, and based on this, we actually can yeah, we take a look at this here. We have an XML sort of a serializer thingy, and this is actually some other function or some other class, actually XML serializer. Then you have some extra properties, which is using an expando object class. Okay, I don't know what this does actually, but this bit here is good for the VB, Visual Basic library, if I can just somehow copy and paste everything out. Okay, so yeah, there are a few classes we will need to import if we ever use that. Alright, yeah, so this is the Ideal Gas XML reader. Then the whole idea of that is to just extract these 5 properties: the ideal gas, heat capacity, A, B, C, D, E, and then once it's done that, this iXML, this Ideal Gas XML reader is supposed to package all of this into an object. Okay, package this into an object and then send it back to the DWSIM library Ideal Gas CP calculator. Okay, once it's here, this DWSIM library Ideal Gas CP calculator will use an engineering unit converter. Okay, why is this good? If you take a look at some of the common NuGet packages, okay, this is a very good dependency. If you type engineering here, you have the first thing that comes out is this thing called engineering units. Okay, you can actually add this the NuGet package to your .NET Core library, or .NET Standard library. You can see this actually supports .NET Standard 2.0. Alright, what does this do? This is very interesting thing. It allows you to specify, for example, you look at this mass flow rate. Okay, mass flow equals new mass flow, blah blah blah. What's your value? And then you can actually specify the unit over here. So all of the things over here have specific units. Alright, it will make it very explicit to the user that, you know, we will have all these units over here. Okay, we'll have all these units right here, so there'll be no ambiguity when it comes to units. So this is very good practice. Okay, all of this is written in C#. So this is the engineering units library. Okay, you have to use the engineering units, and you have to put here using engineering units. So a lot of things here. Length units can be in miles, mass units can be in kilograms, volume units can be in cubic meters, so on and so forth. Okay, there's a meter, hectogram per second. What is a hectogram? Oh, minus 10 kg per second. Okay, sure. Okay, you can do lots of things on this. You can do square root, absolute, can export it as well, I guess. Yeah, and then you can also do some averages as well. Okay, force the quantity to be in some sort of a range. Okay, you can do checks on that, combine methods over here, but yeah, this is just a convenient thing. Yeah, but yeah, it's good to use these engineering units. I mean, yeah, these engineering units can do a lot of things. Maybe there's some underlying code, may or may not be written right, but it's in a NuGet package, and that's I don't care what goes on underneath. I do not want to deal with that at that level. I just want to use it as it is and just be done. Okay, if you want to write software, you can use the solid principles, but if you're just going to use a piece of software and it's already documented and everything, and you're only going to use it and you're not going to touch anything inside the code, the solid principles doesn't really apply. In this case, I do not need to check whether the code is going through all it to apply these solid principles, but I'll just use the code as is, right? And let the developers there deal with how they want to write the code properly. Okay, so this is the engineering units thing. Okay. So yeah, this is all it's supposed to do. It implement one of the implementations. I will just call it the engineering unit converter, which will take this IEnumerable. Okay, it will read this IEnumerable, and then it will output it as an XML data object, which will put it into this DWSim library calculator sort of a thing. So this is a list. Okay, it'll probably be some sort of list which I pass into here. This this is a list, but at the end of the day, it's an IEnumerable interface. Okay, it's an IEnumerable object. Okay, but it'll be packaged as a list. Okay, so this output, the actual output here, okay, in this the actual output of this of this thing here, it will be a list. Yeah, but this okay, so this thing is supposed to okay, I'll put the output here. Output the IEnumerable, but a list. It will be using a list to implement this IEnumerable thing, because that fits in well. So it will output a list, and then this engineering unit converter will take all the elements of this list and then write a new list, and then put it back here. Okay, put it back here so that this thing actually will take the list in, right? It will take the list in. It will take the list in. All right, the list of coefficients in. It'll take the temperature from here. Okay, and then it will just output the CP at the end of the day. A bit complicated, but that's what the plan is. All right. So now after mapping this out, actually, I think this is enough for this video. But hopefully can get this started, put it on GitHub or even NuGet maybe. I don't know. But yeah, gotta get this thing started now that everything is more or less planned out. Okay, more or less planned out. We want to make sure each component is working. So we might consider doing some unit testing, and we'll probably explain and go through what unit testing is. We using this example, and then hopefully assemble all this code together just to calculate one simple heat capacity. But why is it good? Because I will be able to access all the data from this library right here, from this XML file right here. I'll be able to access all these compounds, like methane here. Okay, the methane, it has a CAS number, formula. All of these things are accessible. Propane, ethane, a lot of properties here. I don't know whether there's water. Okay, oh, there's a water compound here as well. Okay, water compound. All right. So there's some vapor pressure, critical temperature, everything over here. So these are things you can use with a Ping Robinson or something like that. So yeah, I think, right, yeah, that's it. Maybe I want to I'll see how to actually implement all of this code in actual C# and Visual Basic. Hopefully we'll use we should be using as much of the XML things over here as possible, since the code is already written. I don't want to waste the code, but nevertheless it doesn't look very inviting. Okay, but we'll see. Okay, catch you in the next video. Hopefully by then I'll have something a little more concrete together. Okay, bye bye.